Hello again, this is Glenn from Endless Innovation Mud USA. Today's going to be all monitors. This is a continuation from our exhaust series, digitizing to engineering to machining. So what we're going to focus on today is, we're going to go through really quickly what we've done with our digitized part right now. Walk through some of the steps we used in our SolidWorks, some of the design assumptions that we made, and some of the changes we made in order to make it usable for machining. And then we're going to quickly just run over to our CAM package, just show you what the cutout of the machine component will look like, and then the next episode will actually be back in the machine making it. Excuse me. So the first thing we're going to start with is our modeling package. So what you can see on the screen right now, and I'll zoom up because I know the camera's a little far away from the monitor, is this is the part that was actually digitized from the previous episodes. And one of the things about digitizing a part is that when you digitize a part in the fashion that I did, a lot of the lines, the outline of the part, they're all splines. They're not actually arcs and true lines. So for machining, that's not very useful because machines really can't deal with splines. They actually need to work with true data with lines and arcs. So the first thing I had to do here was I had to convert all of these splines into true geometry. So that was the first thing we did here, and that's represented by this model here. And you can see all the little facets all around the model. That's actually the software breaking all those splines down into real true geometry that have distance and radiuses and things like that that a tool path can run on. So after we did that, we had to make some assumptions on the data we actually digitized. And some of the things we had to look at were how we were actually going to hold this part when we were machining it, and then what we truly believe some of these round features were expected to be. And what I mean by that is when you digitize a part, you're going to get a circle, but it might be something in between what a true dimension might be. It might be, instead of a ½ inch, it might be 0.49995. So we have to go through and make some assumptions on a lot of these features to make them true to what they really are. Now, if we were going to just grow this part as a 3D part in a 3D printer, which we'll show you in a different episode, then we would just leave it the way it is. But this is actually going to be a functional part that has to be mounted up to the manifold. So some of the things I did off the get-go was we started with features that we knew we were going to have to make somewhat true when we were making the part. So on the bottom here, on the original part, there's this little curvature here which kind of waves along the bottom. And for us, once we machine this part, we have to flip it over and we have to have some true features to hold on to. So what I did was I actually took and made a cut on the bottom side of that part, basically this cut right here, to give me a real true straight surface to start working with on the bottom. It doesn't affect the function of the part, it just gives me a good feature to work with. And then the next thing we had to do was, since we know that the customer actually needs to get access to these holes for getting some pressures and test data, that's not part of the scan data. That's something we actually have to put in. So the next thing I did was actually just added some feature holes that go straight through the part, and to actually communicate, and you can kind of see here with hidden lines, they go through every feature straight through the manifold into the holes where the data is going to be taken. So those are the features that we had to add to get them the data you wanted. The next thing we did was we went through and we had to make some determinations on these little pinholes. Because the pinholes, when they were digitized, they weren't truly round. So what we did was we actually just took and made circular features close to where those pinholes were and made them some generic dimension, like a 7/16 or a 3/8 and things like that. So those, again, are now true holes. Working further down the part, the next thing we had to do was, because this feature, when we stand it up to actually put these mounting or these portholes in, this is actually a curved surface. And we really can't machine and drill a hole on a surface that's curved. So what we did was we added a little feature here. Again, it's not going to affect the function, where we put a flat on the part to actually give it some place to drill to start finding its center and actually drilling the hole. Then what we did next was we actually went through, and up on the top here, if you can remember from what the model looked like, this part was actually split into two pieces actually on the manifold. So where the intersection of this arc and these two sides came together, it wasn't a very clean feature. So we added another feature in there that would actually make a full true radius that we could get a ½ inch end mill through. And then the last thing we did was, once we have this part machined out and have the profile machined out, we have to flip it over and actually cut the material off the back side. So in order to do that, we're going to have to hold it in a vise or some type of fixture. So what I did was I ended up taking, and I'll go back here real quick, these are the normal tips that were on the top of the manifold. I ended up putting a cut in there that actually cut all those tips off. Again, it doesn't affect the function of what the client needs, but what that allows me to do is actually have two flat surfaces, this one here and this one here now, that are parallel to each other, machined in one operation, that I can now flip this over and hold it in a vise with. So those are some of the design considerations we took into play. We made these holes true. We made all these pinholes true. So now they're real features that are machined, and again, they don't, the changes we made are down to the thousandths of an inch, so they don't impact the function. So what we're going to do now is we're going to take this model and we're going to create some drawings for it, and then we're actually going to dump it into our CAM package, and I'm going to show you that real quickly. So now that we have this feature model, we're going to move over here to this screen. This is actually our CAM package that we used. We had a couple different options here because we could have actually water jetted or plasma cut this profile out, but we knew that the top surface of this had to be flat because there was going to be a gasket on there and it had a seal for the testing. So we decided just to machine it out of the machining center. So instead of using a 3D part, I actually broke it down into some 2D views where I could put tool paths on. So basically, if I run the part real quick, you can see that this is the bar stock we would start with. And if I play it, that's actually machining, cutting around the part, putting all the holes in. And basically, this would be the pattern we'd be left with. And this material on the bottom here that wasn't cut away, that's what we're holding into the vise while we're cutting. So that's the material we have to remove, and that's why we put these extra flats on the top here so we can hold onto this part while we cut this back material away. So I don't want to go into detail how we actually programmed the part. I just want to show you that that's the process we would have used. We went from the solid model over in SolidWorks into our CAM package, and the next episode what we're going to show you is we're going to show you machining this part out on the machine, and it'll look exactly like this. We'll have a piece of flat stock, and then you'll see it start cutting out some of this material. So until the next time, this is Glenn from Endless Innovations Mud USA, and we'll see you at the next episode. Thanks.